Hey everyone, so today we're gonna introduce my project HCE Explainer, which explains the result decided by deep neural network for the image classification. So first we have the login page, and I will use my email to log in. And now for the first module, we will have option bar and the function bar. So for the option bar, provides various image category data. So we can choose from them and choose the model to perform semantic segmentation because our method is based on semantic segmentation and superpixel segmentation. So basically, this project measures the performance of the semantic segmentation model and measure the effect of these models to the final result. And for the functional bar, we will demonstrate the core result of our method to explain why the neural network decide this picture is, say, labeled as tabby. So basically, we demonstrate the input image, and we use the GoogleNet as the pre-trained classification model. And when we click Start Prediction, we will have the output, which is tabby. And for the right column, we have the prediction explanation. So it basically determines the contribution of each concept in the image. So concept is like this area. The deeper the red, the more positive the concept's influence on the decision for this output. So basically, tabby's head is the most important concept for the decision, and then the tabby's chest, and then the tabby's body. So for different categories, we can say it's bird, and when we click Start Prediction, we will have the output, and similar to the tabby, we will have the top 3 important contributions for the decision. Because we estimate the performance of the segmentation for the final result, we can change like to ARRA-SPP, which is supposed to be the rawest model for segmentation. So we start prediction. We can see that there was some blue area. So the deeper the blue, the more negative the influence. So basically, that's what our HCE methods do to take an input image and extract some feature representation from the DNN model and try to research to explore the underlying pattern in the DNN model and explain as a heat map. And then the second module is to evaluate the semantic segmentation. Basically, we quantify some metrics that we want to know, like the pixel accuracy and the mean IOU. So the IOU stands for the intersection over union. So basically, we use these two metrics to evaluate the semantic segmentation models. So we have the example image here to see the real performance of every semantic segmentation. So we can choose the model we want to evaluate. In the following work, we may support you upload your own semantic segmentation model. And for these models, we evaluate them on the Pascal VOC 2012 dataset, which is a classical dataset for image classification. So we can choose all of them to step into the next step. And then for this module, we also have the options bar and the function bar. The left side of the options bar provides various images of the same category. So with the default category being tabby cat. So the right side of the option bar will offer, category selection. So we can choose different categories and see the result. And for the function bar, we basically demonstrate the two-level segmentation result, which is the object level and the component level. So we can further use these different level concepts to further our explanation and research. So first we have the input image, and then we will conduct the semantic segmentation for the input. And basically, we will have two patches in this level. So this result is processed by the semantic segmentation model we chose. So basically, we chose all the models in previous steps. So we have 3 models here. And then for the component level, we basically conduct the superpixel segmentation based on the object level patches. And then we will have, like 20 or 30 different patches with fine chorus. And then if we change the image in the same category, we can see similar results as they are conducted by the same semantic segmentation model. We evaluate these category-wise and image-wise. So for the same category, we can see the different results that the main object in different background will be slightly different after the segmentation. And then if we change a category to sorrow, and so basically this model is pretty good. So most of the category can well performed. And then if we change a model to FCN, that will be not so good. And if we chose the this bird and we chose another model, and we can see the target area becomes smaller, which is not expected. So from this step, we can have a fundamental idea about how the semantic segmentation model affects the performance of the feature representation. Then we move one more step to the concept tree. Basically, after we segment different concepts from the image, we want to cluster the concepts in different level. So this is our hierarchical name came from. So we want to further research some similar pattern in the same cluster and further perform the explanation method on them. So for the tabby, the image level is all the images we put into the model. Basically, every category we chose 50 images from the ImageNet, and then we will conduct the semantic segmentation like the step we demonstrate on the last step. We will cluster the same object in the object level, like the cat will be clustered together and the background will be clustered into another category. And then based on these cats, we will further determine to cluster their ears or eyes or their mouth or the body or leg into different detailed patterns. And for background, we may not care much about it, but we still can divide them for clustering. And we can change another category. It takes some time to process these steps because we need to process all the data set real time. And then for the sorrow, the interesting thing is that we are not only segment the horse, but also we split the people near the horse. So maybe we want to ask if the person near the horse will affect the model to determine whether this photo will be classified as a horse or not. So we will see in the next step. So basically the same idea. We will further to cluster different clusters. Like for the people, we may want to process them into fine chorus details like the head or hand. And for the horse, we may want to get their head or the leg or their back or something like that. And then we have different concepts in different level, and we can manually label some cluster category for them, and we can step into the next module. So for this module, we will quantify their contribution value for the final result. You can directly see the function bar. So you can see that, so for the first row, left one is the contributions heat map for object level segmentation. And for second row, is the component level segmentation, and the left is the heat map, and the right is the segmentation result. So how can we better understand these images? So we performed a local concept tree explanation. For the object level, we use the Shapley value and the feature representations from our cluster result. We determined that the tabby have the like 34% values for the neural network to determine this image is tabby, and background just have like 1.5%, so it may not have so much contributions. And we can further break down them into like different components like the head and the chest and trunk to see which part contributes the most. So the tabby's head is nearly the half of the contributions of tabby. So we may consider that the head is an important contributor, and it aligns with our intuition about why we want to classify it to be tabby. And then we can change another category to sorrow. Can have a same idea. We will have negative value like other, which may have negative effect for the final classification category. And background may also contribute to this category because like we can see some green grass on most of the sorrow image. So it also have like 4.8% of contribution for that. But the main contributor is still the sorrow itself, like the trunk or the main body of the horse can contribute to like 88 to the final result. So based on these local concept tree explanation, we can see that how the neural network understand the image and to determine whether it aligns with our human knowledge. And take a further step, we can determine whether we want to trust this model for our task. So it will be very helpful if we want to heavily use the deep neural network in our like some related heavily to the safety or security, like some self-driving or the robotics. This method will be very helpful in these areas. Then we can have a matrix on a large scale data to see how this method perform and to quantify the performance. Right, so this page is basically the impact of different semantic segmentation algorithms on explanation results in the matrix. So we basically use SSC and SDC to quantify or evaluate our method. So we can first have a intuition is that the object level, the heat map is really well, except for this LRA SPP. And for a component level, because we based on the object level, if we perform well on object level, it'll be more possible to have a better result on component level, right? And we can change another category like sorrow. Basically the same idea, right? So we can use this step to have a pre-process for different semantic segmentation model to see whether this model suits your data set. And we can have a quick idea about the overview of your data set. Then for the data, we can see that the DeepLab v3 is no doubt the best model for most of the tasks. And for these three categories we chose. And FCN also did not bad on some specific categories. And also we want to use the consistency to see that if we modify the ranked concepts and measure the classification probability will change before and after modification. So say if we remove most important contributors, if the probability will be reduced or keep same. If reduced, we will regard it as a expected result. If it's keep same, we will not like really want this result. So basically that's how we do in this project. And I hope this makes sense to you and hope to see you on next video.